Welcome to Chapter 9, problem number 46 on page 298. Once again, we are doing a hypothesis test. So when we read the question carefully, we can see that this company, Washington Metropolitan Transit, wants a reliable fleet that can travel 8,000 bus miles without breaking down. And so they do a study and they do a sample of 64 buses, so that will be a t value. They find that the average time between breakdowns is 8,210 bus miles, and with a standard deviation of 625 bus miles. So those are the facts, the numeric numbers anyways. In part A, it says, is there evidence that the population mean of bus miles is greater than 8,000? So this now is our first one-tail test. And because it says the bus miles are greater than 8,000, this would be a right-tail test. So as I've started all the other examples in Chapter 9, I start off with a two-tailed Z-score test. We have a sample, and we have a large sample of 64. And so I'm going to go to hypothesis test, and it's a right tail test. So in this particular case, I put in the null hypothesis that the bus miles are 8,000. I put in a 5% level of significance. I have a 64 bus sample. The sample mean turned out to be 8,210 bus miles, and the standard deviation is 625 bus miles. So in this particular case, we can see that the p-value is 0.005, which is less than the level of significance. And it tells us in our conclusion in B18 to reject the null hypothesis. So what does that mean? The null hypothesis would have been the fact that the bus miles were 8,000 or less, because the alternate hypothesis would be that the bus miles were greater than 8,000 bus miles. So remember, the null hypothesis always has the equal sign in it. So in this case, we have less than or equal to for the 8,000, and we have greater than for the alternate hypothesis. So we can prove mathematically that the null hypothesis is not correct. So we would reject the null hypothesis, and we would accept the alternate hypothesis. We didn't necessarily say it was true, but we accept it. It's a technical little difference. All you need to do is reject the null hypothesis or do not reject the null hypothesis. And you can see the conclusions are done for you. So that is the answers for part A. And the p-value in part B, I've already mentioned, a 0.005.